find the Thevenin's equivalent of the circuit shown in figure below. To the left of the terminals A and B here, A and B terminals are there. Then find the current to the RL when RL value is 6, 16, and 36 ohms. So this is the circuit is given here. So what the problem is they are asking is you have to find the Thevenin's equivalent across the terminals A and B here in the circuit. See, so you have to find Thevenin's equivalent across these two terminals. And after finding the Thevenin's equivalent, then you have to find the current through RL, through this load resistance. RL means load resistance when RL value is 6, 16, and 36 ohms. So now first we have to find out Thevenin's equivalent as well. Well aware that Thevenin's equivalent means what? About any circuit, any linear circuit across the two terminals can be reduced into a single voltage source and single resistance in series with the voltage source. That is the Thevenin's equivalent. Now here in this circuit there are two voltage sources, two independent voltage sources we have. One is 32 volts, another one is 2 ampere current source. Right. Now across these two terminals A and B, we have to find the Thevenin's equivalent. For that one, what we do is first you remove this RL. Then, since the Thevenin's equivalent circuit contains one voltage source and one equivalent resistance RTH, and therefore first we have to find RTH. So to find RTH, already I told you two methods. There are two methods to find the RTH, and since this circuit contains only independent sources, that is both voltage and current sources, we use the method 2, right? So general method reduction of resistance using series parallel reduction technique. So now we find RTH by turning off 32 volts and voltage source, replacing it with short circuit. This voltage source we replace with short circuit, and the current source we replace with a open circuit. While you are finding the equivalent resistance across the terminals A and B, then the circuit will look like this. After turning off this voltage source or reducing this voltage source to 0. So a voltage source is reducing to 0 or deactivating the voltage source means short circuiting the voltage source, and deactivating the current source means open circuiting the current source. Now, when you open circuit the current source and short circuit the voltage source of 32 volts, then the circuit looks like this. So if 4 ohms here, and this is short circuited voltage source, and since the 2 amperes current source is open circuited, there will not be any current here. Therefore, that is we have removed this 2 amperes current source. Therefore, you have to find RTH looking from this end like this in this direction. Now, when you looking the circuit from these terminals A and B, then these two resistors are connected in parallel fashion. 4 ohms and 12 ohms are connected in parallel, and the combination is in series with 1 ohm. Therefore, that is how we have written here 4 in parallel with 12 plus 1. That is, this is in series. So series resistance summation chestam. Parallel resistance product by summation. So when there are two resistors are in parallel, what is the equivalent resistance? Product by sum. That is product of those two values, two resistances divided by the sum of the two values of the resistances. That is 4 into 12 by sum means 12 plus 4, that is 16 plus 1. That is, this is in series with that. E combination in series with this. Therefore, we can write it here as this one, and then we'll get this RTH as 4 volts. So likewise, we find the RTH here. Then to find VTH. Next one is we have to find the VTH to obtain the Thevenin's equivalent. So to find the VTH, what we have to do here is we have to open circuit these terminals. Ante mana original circuit idi kada. Ee circuit lo open circuit chesi ikkada voltage find out cheyali. So that voltage ne, that VOC open circuit voltage, we call it as VTH. So we have redrawn the circuit in such a way that the load resistance is removed, and now we are going to find out the VTH. So how do you find the VTH here? If you look at this voltage across the terminals A and B here, so in 1 ohm resistance, since it is open circuited, there is no current here in 1 ohm resistance. Therefore, when there is no current, there will not be any voltage drop here. Therefore, what is VTH? VTH is same as that of the voltage across the 2 amperes current source. And this 2 amperes current source, if you carefully look at that, it is parallel to the 12 ohms resistor. That means the voltage VTH across the terminal A and B is same as the voltage across 12 ohms. That is why we have designated this node voltage as VTH. Right. Now we apply the mesh analysis. Yep. You can apply mesh or nodal analysis, whichever is convenient. You can apply it here to find VTH. Yep. So now we have to find the voltage across the 12 ohms, and this voltage across 12 ohms will directly give you VTH. So now here I took this is one mesh and this is another mesh. So mesh current I1 I have assumed in this direction, mesh current I2 I have assumed in this direction, and therefore if I apply KVL for mesh 1, that is this one. So what I will get here, it is you are going from minus 2 plus, that is why it is minus 32 volts, and here it is 4I1 plus 12. In this direction, the current in the 12 ohm resistor is I1 minus I2. Since I2 is flowing like this, I1 is flowing like this. Therefore, 12 times I1 minus I2 is equal to 0. This is the KVL equation of mesh 1. then the KVL equation of mesh 2 if you take. So that while you are writing the KVL equation of mesh 2 here, here this is the voltage VTH and this is the same voltage VTH. So you need not write mesh equation here. Why? Because I2 have assumed it as, and the current into current source is 2 amperes and I2 is also have assumed. So I can minus 2 amperes. This is I2 మనం clockwise define చేసాం. But whereas the 2 amperes current source is flowing in anti-clockwise direction like this. That is why I2 will become minus 2 amperes. So once you get I2 as minus 2 amperes and substitute that in this equation and solving for I1, then you will get I1 as 0.5 amperes. Therefore, once you get the I1 current here, so as I mentioned earlier, you want to find out VTH, and this VTH is same as the voltage across the 12 ohms resistor. Therefore, VTH is equal to 12 into what is the current in this one? It is the summation of two currents I1 and I2, but I2 is flowing like this, I1 is flowing like this, kabatti, therefore summation means I1 minus I2 you will get. So I1 is 0.5 and I2 is minus 2, therefore what you will get here is 12 into 0.5 minus of minus 2, that is plus 2, when which is equal to 2.5 into 12, which is nothing but 30 volts. Therefore, the Thevenin's voltage, you will get it as 30 volts. Right. Therefore, this is your Thevenin's equivalent. After finding the Thevenin's voltage and Thevenin's resistance, this is the Thevenin's circuit. See here, this is the Thevenin circuit where you have a Thevenin's voltage of 30 volts is connected in series with a Thevenin's resistance of 4 ohms. Already we have determined the Thevenin's resistance as 4 ohms here, and we have reconnected this Thevenin's equivalent to the terminals A and B once again. అంటే మొత్తం ఈ సర్క్యూట్ అంతటిని కూడా థెవెనిన్స్ ఈక్వివలెంట్ కింద రిప్రజెంట్ చేసాం. దాన్ని మళ్ళీ రీకనెక్ట్ చేసి ఏబీకి. ఎందుకు ఏబీ దగ్గర ఇంకోటి ఉంది లోడ్ రెసిస్టెన్స్ ఉంది కాబట్టి ఇది లోడ్ రెసిస్టెన్స్ కనెక్ట్ చేసాం. Now our aim is next aim is to find IL when RL is 6, 16 and 32. So first you take RL is equal to 6 ohms. So when you take RL is equal to 6 ohms, that is see here it is a simple series circuit. So two resistors are connected in series. What is the total current here? Total current IL is equal to VTH by RTH plus RL. It is series kabatti. So RTH is 4 ohms and RL is known, not known, having different values. So that is why we have represented IL expression as 30 by 4 plus RL. Now you substitute RL is equal to 6 ohms. So then you will get so now when RL is equal to 6 ohms, so we will have IL as 3 amperes and RL is equal to 16, then we will have IL as 1.5 amperes and RL is equal to 36, then we will have 0.75 amperes. Right, like that we have to find this one. Then we will see one more example which contains dependent sources. So ఇప్పుడు వరకు మనం చూసిన example ఏంటంటే independent sources ఉన్నాయి. దాని నుంచి Thevenin's equivalent ఎలా కట్టాలో చూసాం. Now we will see one more example with dependent sources. So look at this diagram where we have to find the Thevenin's equivalent across the terminals A and B here. Right. So to find volt equivalent circuit across the A and B terminals, we have to find both RTH and VTH. Now let us first find out the RTH. Since this circuit contains a dependent source, what type of dependent source it is? It is a voltage dependent voltage source. So because the magnitude of this source is depends on the voltage Vx, where the Vx is the voltage across the 4 ohm resistance. That is why this is a voltage dependent voltage source or voltage variable voltage source. So since this circuit contains one dependent source and one independent source, the method 2 which we have considered earlier by using the series parallel reduction technique is not applicable to this one to find RTH since it contains dependent sources. So method 1 you have to apply. So method 1 in the last class which we have discussed is now applied here. So what is our method 1 states? Just for this circuit, here look at that, where you want to find the equivalent Thevenin's equivalent circuit. There you connect a voltage source, a known voltage source of magnitude 1 volt. Voltage source connect చేసిన వస్తుంది, కరెంట్ సోర్స్ కనెక్ట్ చేసుకుని చేసినా వస్తుంది. Right. So now you connect a voltage source here, then reduce the circuit. Independent sources ఉన్నాయి అనుకోండి, independent sources ఉంటే వాటిని deactivate చేసేసి only dependent source నుంచి you have to apply a voltage source across these two terminals where you want to find out RTH with a magnitude of 1 volt. Then find out the current supplied by this voltage source, known voltage source V0. ఇది ఎంత కరెంట్ సప్లై చేస్తుందో అది మనం ఫైండ్ అవుట్ చేయాలి. సో ఇది ఇప్పుడు సర్క్యూట్ RTH ఫైండ్ అవుట్ చేయడానికి మనం రీడ్రా చేస్తే సర్క్యూట్ ఇలా వస్తుంది. సేమ్ సర్క్యూట్ ఇక్కడ ఏం చేసాం, వీ హావ్ కనెక్టెడ్ వోల్టేజ్ సోర్స్ అండ్ డీయాక్టివేటింగ్ ది ఇండిపెండెంట్ సోర్సెస్. ఇక్కడ ఒక ఇండిపెండెంట్ సోర్స్ ఉంది, ఏమిటది కరెంట్ సోర్స్ ఉంది కాబట్టి దీన్ని డీయాక్టివేట్ చేస్తాం. డీయాక్టివేటింగ్ ది కరెంట్ సోర్స్ మీన్స్ వాట్ ఓపెన్ సర్క్యూటింగ్ అంటే ఇక్కడ ఓపెన్ సర్క్యూట్ అయిన ఇక్కడ డ్రా చేయలేదు. రైట్, నౌ వీ హావ్ టు ఫైండ్ అవుట్ I0. Now we have 3 meshes, 1, 2 and 3 meshes, and mesh currents are, we have assumed it as clockwise direction. Then applying mesh analysis to loop 1, that is KVL to loop 1 of figure A. Then ఈ loop కి మనం KVL వేసాం అనుకోండి, KVL వేస్తే వస్తుంది -2Vx, ఈ డైరెక్షన్ -2 ప్లస్ వెళ్తుంది కాబట్టి -2Vx, and ఈ డైరెక్షన్ లో ఇది 2 times I1 minus I2, 2 times I1 minus I2 is equal to 0. And if you simplify this equation, then you will get Vx is equal to I1 minus I2. Right, then but -4I2 is equal to Vx. Why? You look at that. What is Vx here? Vx is equal to Vx with polarity plus and minus is given by Vx is equal to 4 into current through this one. Current through this one is I2 కదా, I2 ఎలా ఫ్లో అవుతుంది, ఇలా ఫ్లో అవుతుంది. I2 ఇలా ఫ్లో అవుతుంది కాబట్టి యాక్చువల్గా పొలారిటీ కింద ప్లస్ పైన మైనస్ రావాలి. కానీ మనకి Vx we have defined the polarity as పైన ప్లస్ కింద మైనస్ రాసాం కాబట్టి సో దట్ ఈస్ వై వీ హ్యావ్ టేకెన్ -4i2 ఈజ్ ఈక్వల్ టు Vx అందుకు కరెంట్ ఇలా ఫ్లో అవ్వాలి అందులో మైనస్ సైన్ వేసుకున్నాం అండ్ దేర్ ఇక్కడ Vx ఈజ్ ఈక్వల్ టు I1 - I2 అనుకున్నాం అంటే అదే ఇన్ ప్లేస్ ఆఫ్ Vx we substitute -4i2 దెన్ అందులో సబ్స్టిట్యూట్ చేస్తే వాట్ విల్ గెట్ హియర్ ఇట్ ఇస్ విల్ గెట్ I1 as is equal to -3i2. This is one equation you got. Then for loops 2 and 3 applying KVL produces these two equations. So if you apply KVL for loop 2 and loop 3, so loop 2 లో voltage source లేవు straight away 4i2 plus 2i2 minus I1 అంటే ఇందులో I2 minus 1 plus 6i2 minus I3 right is equal to 0. ఇందులో voltage source లేవు ఇందులో voltage source ఉంది కాబట్టి 6i3 minus I2 ఇది రైట్ ప్లస్ 2i3 ఇందులో I3 ఉంటుంది 2i3 plus 1 ఇది +2 మైనస్ వెళ్తుంది కాబట్టి +1 వేసాం +2 మైనస్ అది V0 అవ్వాలి ప్లస్ V0 దట్ V0 is equal to 1 volt కాబట్టి సో దీస్ ఆర్ ద అనదర్ two equations. Now in this using equation 1, 2 and 3 solve for that, then you will get as I3 as -1/0.6 and I0 is equal to what here if you look at that I0 is same as I3 but in opposite direction, therefore I0 is equal to -I3. Once you get I3 as -1.6 then I0 becomes -I3 that is given by 1/6. Once you get I0 your RTH is equal to total applied voltage V0 by I0. So that is V0 is 1 volt by I0 is 1/6. Therefore your RTH is equal to 6 volts. So likewise you have to calculate the RTH using the method 1, that is here applying an external voltage source with a magnitude of 1 volt and deactivating the independent sources and keeping the dependent sources as it is. Then we will find the resistance, Thevenin's equivalent resistance. Right. Next, after finding the Thevenin's, then our aim is to find VTH. VTH అంటే open circuit voltage across the terminals where you want to find the equivalent resistance. ఇక్కడ మళ్ళీ as it is circuit as it is ఉంచేసాం ఇక్కడ voltage మనం got to find. So for that one what we have to do here is what is the voltage here? The voltage here is same as the voltage across 6 ohms. ఎందుకు 2 ohms లో అసలు కరెంట్ ఫ్లో అంతా ఓపెన్ సర్క్యూట్ అయింది కాబట్టి ఇక్కడ ఎంత వోల్టేజ్ ఉంటుందో ఇక్కడ కూడా అంతే వోల్టేజ్ అంటే మనం if you are able to find the voltage across 6 ohms then you will get a VOC. Now for that what we do here is once again we apply the mesh analysis. So ఇదొక మెష్ అనుకున్నాం టోటల్ గా 3 meshes 1 2 3. సో ఆ మెష్ కరెంట్స్ I1 ఇటు అనుకున్నాం I2 ఇటు అనుకున్నాం I3 ఇలా క్లాక్ వైస్. నౌ ఇఫ్ యూ అప్లై KVL ఈక్వేషన్స్ సో ఇది ఈ మెష్ లో I1 అనుకున్నాం కాబట్టి ఇక్కడ కరెంట్ సోర్స్ ఉంది కాబట్టి కరెంట్ సోర్స్ మాగ్నిట్యూడ్ ఎంత ఉంటే అంతే ఉంటుంది. వాట్ ఇస్ ద మాగ్నిట్యూడ్ ఆఫ్ కరెంట్ సోర్స్? ఇట్ ఈస్ ఆల్రెడీ 5 amperes we have ఆల్రెడీ ఇచ్చారు కాబట్టి సర్క్యూట్ లో 5 amperes. సో I1 becomes directly 5 amperes and then దీనికి సెకండ్ మెష్ ఈక్వేషన్స్ యాడ్ చేస్తే ఇలా వస్తుంది, థర్డ్ మెష్ ఈక్వేషన్ చేస్తే ఇలా వస్తుంది. సో ఈ మెష్ ఈక్వేషన్స్ ని మనం ఇఫ్ యూ సాల్వ్ దట్ మెష్ ఈక్వేషన్స్ దెన్ వి విల్ గెట్ ది I2 ఈజ్ ఈక్వల్ టు 10/3 అంటే ఇది 10/3 వచ్చింది I2. మనకు కావాల్సిన I2 కాబట్టి I2 ఒకటే క్యాలిక్యులేట్ చేసి వచ్చేస్తాం మనం. I1 ఆల్రెడీ 5 వచ్చింది, I3 అవసరం లేదు ఎందుకంటే I2 కావాలి, ఇందులో కరెంట్ కావాలి కాబట్టి. సో therefore what is VOC or VTH? 6 times I2. So 6 times I2 is what VTH and that is given by 20 volts. Likewise you can find the Thevenin's equivalent of this example, right? So ఇలాగా డిపెండెంట్ సోర్సెస్ ఉన్న వాటికి ఇలా చేస్తాం.